Alright, so welcome to my little video here. I'm gonna basically, it's been a while since I've done a video where I talk, so this is gonna be interesting. Anyways, yeah, let me explain my program a little bit, and you can see some code already, but what I'm gonna do is I'm just gonna show you like what my program does. I'm gonna kind of explain, just what it does. It's in a very, very early stage, which is why I'm not releasing it right now. Um, but I do plan on releasing it, just like not until I get some basic functionality with it is what I'm going to. So I'm going to explain everything. So basically we start here, and we're going to open a file, and I'm just using one of my songs. That's always what I use as a test file. So alright, so now I'm going to explain what everything is doing, because it's a bit of stuff, but I'll explain it. So we'll go all the way. Alright, it'll take a little bit of time here, but I want to go through and explain what's going on with my program. So I'll actually open the Orchid wave file, so you can actually, because every wave file is composed of text, raw text basically. It can be reduced to that. So that's basically my concept of this. I'm working at a low level. I'm just going to open up the file that I just opened with my program. So yeah, this looks like nonsense, right? But we're going to view it in hex, and it's going to make a lot more sense. And if you don't know what hex is, I'm hoping that most of you guys, you just do a quick Google search. But it's just a way of data representing data. Anyway, so this is the file that I just opened, right? And we can see this is, let me open a few more things here to sort of explain to you the whole idea of the program, like what it's all based on. So we're going to try to open something here. Let's see. Alright. So we're going to try to find, yep, this is what I'm looking for. So this is basically like my, when I was coding this, okay? This is kind of what I was using as a reference to understand what's going on with the program and how it's, and let me open up another thing because this is kind of important as well. I gotta open this specific one with paint. I know it's weird, but you have to, because otherwise it just looks messed up, because I use the dark theme. So let me just like try to, first we'll focus on this first, because this is pretty important. So this is basically how a chunk is processed. Okay, and so this is just the stuff that I had to learn. And you can research this stuff, but this is like what I looked at. This type of stuff I learned how to extract it, because all you really need to do is open the file, which is what we just did, and we're reading this stuff. So we can read the header. We just have to know like the bit positions, and it's all based on. We don't have to worry about technical aspects, but I'll do my best to explain the overall general thing. So I actually have a piece of Python code that does the extraction, because I thought it was really, really, really ultra simple to do it this way, because they have a wave library and it makes it so simple. Anyway, yeah, so this is telling you, it's just extracted information. I can show you this is the information and the data. This particular audio file is a very high bit rate, so I think I'm not really sure if it has a lot of frames, but that is the total amount of like frames of like basically for the program to process, right? I'm pretty sure something like that. Once again, I'm not 100% sure, but this should be what that is. I mean, I don't remember all of this. This is a little bit older stuff, but yeah. So we're trying to explain this the best I can. So basically, it's reading the header. Right? This is actually reading the header. So this is the sample rate header, and this is, I'm just telling you it is. I mean, you can pause the video or like just look at what's happening. You can actually see these characters are going to match up with here. So audio format, this is what it's reading, I believe. But this reduces basically to the sample rate. So because every WAV file always stores all the information in its header, and that's one thing it stores. So we're just able to read all the information. Then the bit rate, same thing here. It's a little calculation that just gets the bit rate, and like I said, high bit rate. I believe that's in it should be in bytes, because it's 1,411 kilobytes. So that makes sense because the 3 decimals. So you have 1,411 kilobytes per second. But this is bytes per second. That should be the bytes per second. Once again, this is just telling you the amount of samples that are in 1/60th of a second. As I said, this is how I'm setting up the program because I'm just thinking right now static frame rate 60 frames per second. So this is just telling you that that's the amount of samples that are in 1/60th of a second. And this is going to be based on the bit rate. So the bit rate is going to be basically the density of the data. So this is a particularly dense piece of dense audio file. So it's going to have a higher amount of samples, I believe. So here we go. So element in index 5. So that's just saying that that's not related to anything. That's just repeating the same thing. And then now we're actually starting to read it. So this is when it actually reads the data sector. So now we have the real hex value. So we're actually taking, so this whole data sector starting from this red bracket I've marked here. This whole data sector is all the data in the actual file. Like this is what it actually reads. That's like the sample. That's everything. So we're starting here, and it's all stored in little endian, and you can look that up. Little endian. It just means that the hex values are just reversed. So you have FF, and then you have FB. So this is how I did it, right? I was able to, with some code, I was able to take these first, so you can see this is starting at the beginning. And this is basically what I'm able to do. So I'm able to extract every single, and there was one little thing, was that it's 2-channel audio, and that was one thing I didn't realize. So the 2-channel audio means, like, you see this actually repeats, FB, FF, FB, FF. That is just literally the 2-channel audio. So this is like basically saying, it's basically that particular sample is exactly the same. Obviously, these are individual samples. I mean, the bit rate is so high, it's just going to zoom through so quick, because it's like about, I believe it's about a few minutes of a song, so it's going to blaze through this so quickly. But this is like a value, and this is the 2 samples, I believe, that are represented the 2 channels. So these are actually these 2 values are actually basically the same sample. The 2 samples, but in 2 channels. That was one thing I didn't understand. I didn't understand at first, but then I understood it after. And you can see it repeats itself. See again, FEF. And once again, it's reversed because this is putting in a little endian, so it can actually read the real hex value. And it's just reading every single hex value for a sample, for a particular sample. Okay, and it's just going to be a lot because it said it was about 2,940. So that's that, and then basically this is the part that it comes down to interpretation. And like I said, I'm doing everything on a lower level because I'm more interested to do on a lower level, because I think there's more that can happen, more possibilities. So there's a reason why I'm doing it on the lower level. It's because of that. Okay, so anyway, like I said, and this is where it comes down to interpretation. Okay, so we have the full seed. I have generated basically what I've done. It's kind of a little bit of something, but I basically kind of just say, based on the value, like the max value and the min value, I would just say, 0 and 65535, because that's basically 16 bits. You can look that up as well, 16 bits, because it's 16-bit audio. I've only done it for 16-bit audio. So that's, see, there's a lot of these technical things I had to learn, so I'm just showing you this is like what I've done. I think this is a very solid part of the program, and obviously from here it's just like even more difficult, because I'll talk about that later. So the full seed, okay, that is, I've generated now, like I said, the 0 to 25565. I then do that, but then from that, I have a file. I actually think, I don't write to files. I was writing to files, but I realized how slow it was, so I'm doing everything through memory. But basically this is kind of just taking the 0 to 1. So it's scaling the 0 to 25535, which is the size of the 16-bit samples, and it's kind of just taking the average of everything. Well, it's bringing it down to 0 to 1 instead of 0 to 65535, which is why it's this huge decimal. And all I'm really doing is just taking that decimal, and I'm just calling that my sample. And that's the seed I'm going to just use. And I'm hoping that I'm maybe going to find patterns with the seeds, because I know that there's no way that I feel like I should be able to find some kind of pattern. And from here, then it's the interpretation, which I was explaining. And like I said, I might do this in a totally different way, but right now this is like what I'm going to work with. I'm going to see how far I can get, or what I can do with it. So that sample now, that has a seed, and now that basically represents a frame, a single frame. And then now we have to generate a frame based off of some interpretation stuff. And once we do that, then we basically got it. Then you just repeat, read, write, process image, boom. And then after they're all done, you compile them together, compile the images together into a video. That's basically my ideas. Now, I don't know if it's all going to work. I'm going to figure it out. I want to learn, so that's why I'm doing this. But that's what I've been able to do, and it's been interesting just like doing this file processing and learning how the format works and stuff is definitely a big thing, and I did this solid piece of the program. But this is really all I've done so far. So once again here, that's the seed, and like I said, now it's the interpretation. So now you have to interpret this number, so basically how I'm starting to think about it is I'm going to make an interpretation. So I'm going to say maybe these 4 numbers are going to like change some graphics that are going to generate on a frame, and these next 4 numbers are going to do something else. You could do this in so many different ways, and I think that's like a sufficient thing to work with, and I'm going to find out if it's not, and you guys can comment or whatever, tell me about if that's a bad idea or something. So something I'm trying, and maybe it's not going to work. It might not work, but that's okay. I'm going to learn as I go, and I'm basically as I've said or I've written a few things. I'm just doing basically the best things I know and just working with that. And until I find things that are better, then I'll do them, And for now, I'm just going to work with what I think is best, and I'll learn, And the goal is to learn. Even if this is all crap, this is like literally my first programming project, and it's a learning experience. It's very important to have these learning experiences, I think. And working on this project has really taught me quite a lot about programming. Definitely, I mean, I don't know. It's been quite a lot, and it's really been good. So. And I want to continue this and see what I can do with it, and try to continue. I've been trying my best, but the past few weeks we've been playing some games with my friends, but it's been okay. We were trying a few new things, playing some Terraria Expert Hardcore, some things like that. I know I'm getting off topic, but I basically kind of just explained it to you, so that's really all it does right now. I'm just showing you like what the functionality is, what it does, things like that. And like I said, I do plan, and I don't know if I want to make this open source. I really don't know if I want to, because it's kind of like my project. I mean, I don't know. Maybe I'll expand it out, and release stuff and go open. I don't really know right now, but right now I just want to work on something, and this is what I'm working on, and I want to continue. And it's something to think about. This interpretation is a lot more conceptual than the reading the files. Because reading the files, we're like, well, we know what we're gonna do, but this is like now you gotta like design like a whole interpreter for these numbers. That's basically what I'm gonna do and what I'm working on. And yeah, it's a challenge and it's a lot of things to do, but the most important thing is that I'm learning, and this is something that I really want to do, make a really cool audio visualization that is different from other things, not just like a vector and bar graph. And I might do that, just to know how to do it. And maybe a better way to do it I thought about was also using frequencies. Like instead of worrying about a seed and numbers, you just like look at the actual frequencies and do a frequency analysis. That's another thing you can do, and then from there something. So I'm just kind of explaining what I've been working on, what I've done, so other people can understand, because I don't want to exactly release full. It's like all my work. It's like, oh, here's all my work, and everybody can just use it. Like I'm feeling a little iffy about it. I mean, maybe I'm wrong. Maybe I'm wrong, and people should tell me that. Oh, you just freaking release your source code, and I'll help you. Like maybe I should do that. But as of right now, I'd rather just until at least I plan to release. When I plan to release is when I make the decision about when I make open source or not, or I'll just just release it as a program that others can use. And that's like I'm gonna make it like basic, the basic functionality, like what I'm talking about, just even able to generate anything. Because right now we're just reading from files, and I've been doing a lot of conceptual thinking about how I'm gonna really design this part of the program with the interpreter. All right, hello once again. I just wanted to basically I wanted to show that my program is working with multiple files, essentially. To show you that it just works, So my program will only work with 16-bit WAV files right now. Now, I'm not really sure with the other audio formats, but I'm gonna, that's like obviously on my mind. I'm thinking about that. Right now, I just want to add things, and, So I just want to do a bit of, just to show you it works with different files. So we're gonna just take another file here. We'll just take this file right here, and we're going to watch the program work. So here we go. We process the file. That's our seed down there. And then here is our sample again. Same thing, 16 bits. Always need to be 16 bits. Alright, so that's that file. Alright, and you can note that. And then now I'm going to run the next file. So we're going to open another file. This right here, this random little wave file, this is going to be different. These are all the same bit rates, so there's your seed for that one. This one's particularly a shorter one, I'm pretty sure. So yeah, actually took a really short amount of time with this Python script. But yeah, you can see this is this one, and this is a little bit different data than other ones. And we can test it with another one, and this time I'm actually going to do a special case that showing you that why it really doesn't work. So this is I will tell you right now, this is a 24-bit WAV file, and when I open it, ooh, it does some weird things. See, it keeps going, and it's doing something very strange that's not supposed to happen. But if we just scroll up here, oh, so as you can see, the program is properly reading the data on these sectors. However, this is a 24-bit file, so things are going to be different here. I'm not sure about anything really what's going on here. This is some weird numbers. These are really crazy numbers, but it's because the bit rate is higher. So it reads this right here because it's still a WAV file, so it's reading 24 bits right here. So this is, I'm just showing you it's really reading 24. So now we're going to test this with varying bit rates. So that I just showed you, it does, just to show you, it does not work with something that's not a 16-bit file. Now we're going to test it with just two files here I have. One is lower and one is higher. Let's figure out. So that's, I believe, the higher one, and then this one is the lower one. Okay, so these have two varying bit rates. Okay, so our number 2 testbut2 file is going to have a lower bit rate. Okay, so we're just going to open this file and we're going to watch what happens. So it's a really short sample, so now we can see the seed again from the first set of samples that make up a frame. Really short time. Once again, 16 bits per sample. There's our sample rate. This is FM quality, so we can see this is FM quality. And now we're going to test it with the other one that's a higher bit rate, which was in studio quality bit rate, which is testbut. And then here we go, the seed again from the set of samples. And then now we see here the one thing to note, it reads the sample rate correctly. Same thing, 16-bit, but our bit rate is different. 3072 kilobits per second. It's easier to say it that way. And once again, if we look at this, well, that's the other one, and this is this one. So we can take a look, and we can say, okay, details, and we can see this is clearly 3072 kilobits per second. So I'm showing you it's really reading the bit rate. It's actually reading from the header. Once again, and this is I will tell you, you can trust me on this, higher amount of samples, because this is a higher sample rate, which in turn gives you a higher bit rate. Okay, these are basically just two WAV files. I upped the sample rate on this one to DVD quality, and then I turned this one down to FM quality for the sample rate. So now I'm just showing you that it really is reading that bit rate, and it's reading our sample rate for this one. Like I said, this is the higher one. That's the DVD quality. So my overall point is I'm showing you it's working with different sample rates, which are giving us different bit rates. I'm just showing you that it's reading this particular sample rate. Okay, so that about wraps it up. I'm gonna finish the video here. So I really demonstrated the main things, the main points here. It works with different files. For the most part, I haven't, on that everything is maybe perfect. However, for the most part, it does work. But thank you guys for watching, and I hope you have a good rest of your day. Thank you.